Hi, my name is Bhanav and I'm going to solve the sixth question in our MAT104 Endsem. The question is in the description and I'll flip the camera so that we can get started. So the question is asking us to consider this ODE y double dash plus 16y is equal to 4 times the delta function at t minus 3 pi. So our first question is, what kind of real life phenomenon is captured by the delta function if this ODE represents a mass spring system? So it could probably represent when the motion begins. Suppose we consider mass spring system, then this delta function might tell us exactly when the spring reaches max extension. As in, as soon as you put the weight, it is the spring is pulled down to a certain extension, that's its max, before it begins to move up again. So the delta function could represent that, because the delta function represents a sudden spike like so. So delta function at t minus 3 pi would mean at exactly 3 pi there would be a spike that goes really higher, and nothing before that, nothing after that. So I guess in a mass spring system it could represent the start of motion. So which brings us to our second question. Without solving and just using our intuition, sketch the graph of the solution. Since it represents a sudden start in motion only after 3 pi, we can assume that the solution would look something like this, like nothing till 3 pi, and at 3 pi it will move up, and then its sinusoidal motion will start, since it's a mass spring system, like so. Here, nothing till 3 pi and then sudden spike, and it continues. Our third question, the third part involves solving the ODE. So first off, let's write the ODE down. Y double dash plus 16y equals 4 times the delta function at t minus 3 pi. So first off, we take the Laplace transform on both sides. So we get Laplace transform of y double dash plus 16 times the Laplace transform of y equal to 4 times the Laplace transform of the delta function at t minus 3 pi. So we'll start off with the left hand side. The Laplace transform of a double derivative is defined as s square into the Laplace transform of y minus s into f y at 0 minus y dash at 0 plus this term 16 times the Laplace transform of y will be equal to 4 times the Laplace transform of a delta function at t minus 3 pi. Would be the Laplace transform of a delta function at t minus 3 pi would be e power minus t naught s, where t naught is the term here. So in our case it would be e power minus 3 pi s. So this term would be 4 into e power minus 3 pi s. So now in our question we've been given that y of 0 is 0 and y dash of 0 is also 0. So that would mean that this term and this term would be 0. So all we're left with is s square times the Laplace transform of y plus 16 times the Laplace transform of y is equal to 4 times e power minus 3 pi s. So taking the Laplace transform of y common, we get s square plus 16 in brackets equal to 4 times e power minus 3 pi s. Let me turn the page and we'll continue. So now we have the Laplace transform of y times s square plus 16 equals 4 e power minus 3 pi s, right? So we take this s square plus 16 down here and we get Laplace transform of y is equal to 4 e power minus 3 pi s divided by s square plus 16. Now we take the inverse Laplace on both sides so that we can find out what y is. So Laplace inverse of Laplace is just y is equal to the Laplace inverse of 4 e power minus 3 pi s divided by s square plus 16. This we can write in two parts, which is the Laplace inverse of e power minus 3 pi s times 4 by s square plus 16. Now this is where we recall the identity. Laplace inverse of e power minus as times f of s is equal to f of t minus a u of t minus a, and in this case a is 3 pi and f of t minus a would end up being f would end up being this capital F. So f would end up being sine 4t, because Laplace transform of a by s square plus a square is sine of at. So let's write that down here. Laplace inverse of e power minus 3 pi s times 4 by s square plus 16 would be equal to sine of t minus 3 pi sine of 4 times t minus 3 pi times the unit step function of t minus 3 pi. And I checked in Wolfram Alpha, and the graph of this function turns out to be something like this. Nothing till about 3 pi, and then just 4 times t minus 3 pi, high frequency graph. So I guess I was almost right, considering I did predict sinusoidal motion over here. So that's that. This is our solution. I'm the king of math.